Calculating slope from graphs. The target for this lesson is, I can use slope triangles to find the slope of lines. Let's start with vocabulary. A linear function is a function whose graph is a line. Slope is the ratio of the vertical change to the horizontal change in a linear graph. Here are some key ideas about slope that are good to know. A line can have a slope that is positive, negative, 0, or undefined. The first graph below represents a positive slope because to move from one point to the next, you increase on the y-axis by moving upward, and you increase on the x-axis by moving to the right. You could imagine walking up a staircase to the right. The second graph represents a negative slope. This time, you decrease on the y-axis by moving downward, while still increasing on the x-axis by moving to the right. You could imagine walking down a staircase to the right. The third graph represents zero slope. If you imagine walking along a path with no upward or downward slope, this graph is flat, so the amount of slope is 0. The final graph represents an undefined slope. If we use the walking analogy again, a person could not walk on this path. Since there is no slope, we call it undefined. Calculating slope from a graph can be accomplished by finding the ratio of the rise to run. The slope of a line is the ratio of the change in y values to the change in x values. The change in y values is known as the rise, and the change in x values is known as the run. The ratio of the rise to run is often written in fraction form. Example 1. We'll do this problem together. Draw a slope triangle for the line when possible and identify the slope of the line. Problem A. Let's begin drawing the triangle by moving either up or down. In this case, we'll move down 1 unit. Finish the triangle by moving to the right. In this case, we will move 2 units over. The change in y coordinates is -1. And the change in x coordinates is +2. So the slope is -1 over +2. This simplifies to a slope of -1/2. Problem B. Again, we will begin drawing the triangle by moving either up or down. In this case, we will move up 2 units. Finish the triangle by moving to the right 2 units. The change in y is +2, and the change in x is +2. So the slope is +2 over +2. This simplifies to a slope of 1. Problem C. To move from one point to the next, we can move up 3 units. However, we cannot move to the right because the graph is completely vertical. The unit rate would be +3 over 0, but since we cannot divide by 0, the slope is undefined. Problem D. Normally, we begin by moving vertically up or down, but this graph does not change vertically. However, it does move to the right by 3 units. The unit rate is 0 over 3. 0 divided by 3 is 0, so the slope of this graph is 0. Extra example 1. You'll try this problem by yourself. Identify the slope of the line. Pause the video and try this problem on your own. When finished, unpause the video to see if you were able to successfully solve the problem. The answer to this problem is, the slope of the line is -3 over 2. Example 2. We'll do this problem together. Graph the line that goes through the given points. Draw a slope triangle and give the slope. Problem A. Plot the point 2, 7, and plot the point 5, 1. Draw a line through the points. To create the slope triangle, begin with the point on the left, in this case, 2, 7. Move vertically up or down. In this case, we will move down 6 units. Finish the triangle by moving to the right 3 units. The unit rate, y over x, is -6 over +3. This simplifies to -2. Problem B. We'll do this problem together. Plot the point 0, 1 and plot the point 2, 4. Draw a straight line through the points. To create the slope triangle, begin with a point on the left, in this case, 0, 1. Move vertically up or down. In this case, we will move up 3 units. Finish the triangle by moving to the right 2 units. The unit rate, y over x, is positive 3 over positive 2. This simplifies to 3 halves. Extra example 2. You'll try this problem by yourself. Graph the line that goes through the points 3, 7 and negative 1, 5. Find the slope of the line. Hit pause and attempt this example. Check your answer by resuming the video to see if you got the correct answer. The answer to this problem is, the slope is 1/2. Example 3. We'll do this problem together. Graph a line with a slope of 2. Answers may vary on this question, but the graph created needs to have a slope triangle that moves up 2 units and moves to the right 1 unit. Extra example 3. You'll try this problem by yourself. Graph a line with a slope of negative 1/4. This would be a good time to pause the video. Complete the problem by yourself, then check your answer by resuming the video. The answer to this problem is any straight line that moves downward to the right with a slope triangle that moves down 1 and over 4. Answers may vary. Consider this. How do you find the slope of a line from a graph that does not go through the origin? What is the shortcut you can use if the line does go through the origin? What do you think?